the previous sessions, we generated different paths. We used different setting for generating different setting of the path. We created the mesh. We also changing the setting of the control value of the substrate and the tape. We change the setting of them with these options at the left side. Now we will have a look how to change the laser positions. To do that, I regenerate the path and put the ruler on the path. I move the path a little bit at the other side to make it more visible. I also increase the size and then click on Add. I also add this to 100 to have a better discretizations. I make it also slightly larger. And then I click on Add the path. So the path generated like that. Now I would like to create the laser positions. I move this red dot toward here, toward the roller. I click on the head, align the target to change the position of this green sphere, and then I click on Put Laser. I will have a look again and repositions the whole geometry. So you will play with this dot point to recreate the appropriate position for the laser and orientations. The position and orientation of the laser will be updated here. And you will see angle with the main axis here. You could rotate this rectangular laser head. I will zoom in and show it in a better view. You will see this yellow area, rectangular area, will be rotated. And now, if you move it, the whole system will be moved. But how about if we add a relative orientations and the variations of this setting and directions? To do that, we need to import tilt and yaw variations. Click on it, select the file, which could be either text file or Excel file. To see the content, click on Open. So this is the content of the file. The first arrow is a tilt, the second one is a yaw, and you will see the relative variations of them. You could also select another file, which is this one. Click on Open, and you will see at the first view step the relative variation of the tilt is 0, and then it changes to 5 and increase until around 20. For the yaw, we also have the variations, but it is 0. So click on this file. It takes some seconds, and then this window will pop up. You can also change the value of the variation here. This is a relative movement and orientation change of the tilt and yaw. When it is okay, you could select and close the window. To see direction of the tilt and yaw, you will see if you zoom in along this rectangular laser red, you will see the yaw direction and the tilt direction. So, if you now move it, the laser, you will see the changing of the orientations. You will also see the values of the orientation change at this left side of the figure. So if we compare it, we have a 20-degree variations of the laser head along the tilt angle and direction. So this is a function of the import tilt and yaw variation. You could also add the extra laser models. To do that, click on laser models and enter the numbers. I add 3 and 4 along the two direction, tilt and yaw, direction number 1 and direction number 2. This is also the interval and distance between them, which is based on the percentage. Click on OK. So this is exemplar value 3 along the first direction and 4 along the second direction. Click on OK. And when you move this slider, it will update it. The laser will be updated like that. And you will see the numbers which is associated with the laser modules. You could assign then the laser power and laser intensity for each modulus for the analysis later via the process parameters. This is number 1, 2, 3, 4, 5, 6 until 12. For changing the value, you could change the number of the laser modules.